So again, a proportion is an equation that states two ratios are equal. If the ratios of two quantities are equal, then the quantities are proportional. So for example, remember we can write ratios like that with the colon, and we would read that as 1 to 2 and 3 to 6. So the way to show they're proportional is we would rewrite them in their fraction form and check, is 1 over 2 equivalent to 3 over 6? Yes, we can check that using cross products. So remember we were doing cross products last week where we said whatever is on this diagonal has to be equal to whatever is on this diagonal. So 1 times 6 is 6, 2 times 3 is 3. Those are proportional. The other way we can do it is by going and seeing if there's a common multiplier going straight across. So 1 times what gives us 3? 3. Is 2 times 3 on the bottom 6. So because they're multiplied by the same thing, top and bottom, they're also proportional. Okay, we also can solve proportions. So the next example, we've got 28 to 36 and x to 180. So let's go ahead and set this one up and solve it now. So same thing, we're going to set it up as in fraction form. 28 over 36 equals x over 180. So you can either look for a common multiplier. 36 times what gives us 180? Anyone know that off the top of your head? Okay. Maybe. Maybe not. It's not 6. Okay. Or we can do cross products. It's probably going to be the faster way here. So we're going to say whatever is on this diagonal, so 36 times x, or 36x, is equal to the other diagonal, 28 times 180. So what is 28 times 180? Do you not have calculators back there?
He actually has one in his pencil pouch.
Got it. But what'd you get for 28 times 180?
5,000. Wait, no, 50. No, 5,040.
5,040. Okay, so we said 28 times 180 was 5,040, and that was equal to our other diagonal, 36 times x. What's our last step in solving that? We can draw the line and then do what? Divide by 36. Very good. So 5,040 divided by 36 should give us that x value that belongs up top. Thank you, Scarlett. 140. So again, what this is telling us is that a 28 to 36 ratio is equivalent to a 140 to 180 ratio, which is very similar to our scale factors. When we had scaled copies of things, they stayed proportional in the way we changed those side lengths. Questions on anything we got up top? All right, let's move on to this bottom table then. So a blank, a proportional relationship. A proportional relationship is a relationship between two variables where their ratios are equal. If the ratios are not equivalent, then it is not proportional. It says not, so all you have to do is write proportional again there.
Why is there a line there?
Because forgot to delete the word not, so it was supposed to be not proportional, but not still there, so you just have to write proportional. All right, so let's look at some proportional relationships and see if we can fill in a table. So Mrs. Roth has this great bread recipe. I don't know if you guys have heard about it, but she makes a really great bread. You should ask her about it sometime, okay? And in her bread, for every 1,000 grams of flour, she puts in 750 grams of water. She does. She is really exact in her measuring. Not cups, not ounce. It's grams of flour and water. Yeah. So we need to figure out if Mrs. Roth is going to double her recipe and get 2,000 grams of flour, And if she's going to have 4,000 grams of flour, how much water she's going to be putting in for both of those. Okay, so we've got a couple of things here. We can look at these ratios and say, okay, for every 750 grams of water, there are 1,000 grams of flour. So we're trying to figure out how much water for 2,000 grams of flour. Think of it that way. What's happening with the numbers there? By what? You're right. By 2. So you can double the grams of water for this second one. How many grams of water would that give us?
1,500.
Yep, 1,500 or 1,500. Those are both the same. 1,500 grams of water. And then we could do the same thing and say, well, for 4,000 grams of flour, if we look back at our original ratio, how many times bigger is that ratio getting?
4.
Thank you. From our original ratio, always good to go back and compare it to your original or your given, because let's say you made a simple mistake when you solved the 2,000 one, and then you use that one to find your next one. What's going to happen with that next one? It's going to be wrong. If you made a mistake in calculating your first one and you use that to calculate your second one, it's going to be wrong. So if you go back to your original and say, okay, to get from 1,000 to 4,000, this is 4 times bigger, so we're going to make this other one 4 times bigger. Okay, always go back to your original just to make sure that if you made mistakes, they're not impacting the rest of your work. So what is 750 times 4?
3,000.
Oopsie daisies. 750 times 4. That'll do it. Okay. The other thing we could look at is there a common multiplier to get from 1,000 to 750? Anyone know what 1,000 times what gives us 750? What the essentially scale factor of this is? Anyone remember how we got if this was scaled factors, how we got this? You did it backwards. You want to take the new one, 750, divide it by your old one, 1,000.
Wait. I thought I got it. I went the wrong way.
Yeah.
0.75.
Yeah. I thought you said 13.5. Oh. I thought you said 13.5, which I wasn't sure where that number came from. But yeah, 0.75. So that's the other way you could find this. You could say, well, 1,000 times 0.75 gave us 750. So if you would have done this, 2,000 times 0.75 and 4,000 times 0.75, it would have given you those new numbers as well. Okay? All right, let's draw. Same thing, we just talked about scale copies. Those are proportional as well. Go ahead and draw yourself this triangle. And label the sides 1, 3, and 5. Those are going to be our original side lengths. And then our scaled copy is going to be bigger. It's going to have this side length is going to be labeled as a 4. You forgot how to draw triangles?
No, I drew it the wrong way. Like,
Oh.
too small.
Gotcha.
It was smaller than the first one.
I thought you forgot how to draw the shape itself. 3 sides. All right, so this is our original ratio. In the original, the side length is 1. In the copy, it is a 4. Doesn't really matter what our unit of measure is right now. So we can set up a proportion and say, okay, 1 to 4 is equivalent to 3 out of what? Or we can look for that common multiplier. To get from the original 1 to the copy of 4, what did we multiply by?
4.
1 times 4. So we can do 3 times 4. What's the 12? And we can do 5 times 4. We also could look at this and say, okay, to get from 1 to 3, our scale copy is getting 3 times bigger. So 4 times 3 is 12. We could go down that way. Can also set up proportions and those fractions and do cross products as well. So lots of different ways to get the same answer here in solving proportions, okay? What did we say? What was this one, 5? Any questions on the front side? All right, let's go to the inside then. All right, so it says each table represents an example of a proportional relationship. Complete the table. So let's do this first one together, and then I'm going to let you work with some partners, and we'll go over answers here in a little bit together. So for this first one, we've got a recipe with 1 cup of milk and 2 tablespoons of cocoa is our given ratio. So the cocoa is what compared to the milk? Eva? 2 times more. Yep. 2 times 2 gave us 4. 3 times 2 gave us 6. So if we're given 10 tablespoons of cocoa, how much milk? 5 cups of milk. If we're given 10 cups of milk, we have 20 tablespoons of cocoa. And the milk, again, is half the size of the cocoa, so what's our last? 20. Very good. Everyone see what we're doing here? If you can't find a common multiplier, again, use your calculator to find that common multiplier, and you can divide the new by the old, and that will tell you what you're multiplying by. Okay? All right, work with the people around you. Blake, if you want to move and join somebody, you can. See if you can fill in. Let's just do the top row and make sure we're on the right track for the top row. We'll go over these in about 3 or 4 minutes, and then we'll do the bottom row, okay? Go ahead and do that now. All right, here we go. Let's make sure we got these right. Here we go. Hi, friends. Let's go. Okay, let's make sure we've got these right before we move on and get too far. So for the driving at a constant speed, what was your kind of factor, your rate here that you were multiplying by, Maddie?
60.
Times 60. So 0.5 times 60, or 1 times 60 gave us the other side. So what were you missing? What was your distance for 5 hours? 300? Oops. What about for the time for a distance of 1,000?
It's 16.6 repeating.
16.6 repeating hours. Or does anyone know the fraction version of that, if you were to write that as a mixed number? 16 and, what did we say?
1/6.
Ooh, close.
160.
Nope. Okay, I guess we weren't that close. 2/3?
Oh.
Right.
2/3? Our thirds, remember thirds. 0.33 is 1/3 and 0.66 repeating is 2/3. Okay? For the next one, earning money babysitting at an hourly rate. So what was the hourly rate? 1 hour was how much money, Eva? $15. Very good. So first box there was 15. So if you babysat for 5 hours, Elise, you would get
75.
$75. If you babysat for 8 hours, McKenna.
120.
Ooh, not 120.
Huh?
Is my answer key wrong?
Yeah, I think so. Wait. Yes.
Sure is.
Yep.
Good call, you guys.
We're so smart.
Anderson, what about $150? 10 hours, very good. And what about for $500, Lily? 33.3 repeating, or what would the fraction form be? Hint, I just told you. Scarlett. 33 1/3, very good. 33 1/3 hours, good. All right, I want you to move on. Okay. Bottom row you can do. You don't need to do it with a fill in the blank because we'll do that together and fill that in together after we finish the tables. But pay attention to this last box. The directions shift a little bit. The tables are completely filled in. It says for the tables below, determine if the relationship is proportional or not proportional. So these left two, you're going to fill in the table. The last one, you're determining whether they're proportional or not. We'll take about 5 minutes here, and then we'll go over answers before the end of class. Yes, Eloise. Yep, so you're going to look at this one first and say, is this a proportional relationship, yes or no? And then you're going to move to this one, is this one a proportional relationship, yes or no? Meaning, are we multiplying by the same number there, okay? Here we go. First table, who can run us down your answers for the buying cookies, the prices you had? Blake.
So, for 3, the total cost is $4.50.
Good.
For 5 cookies, it's $7.50. For 10 cookies, I got $15. And for 25 cookies, I got $37.50.
Excellent. Those answers are all correct, so make sure your table matches what Blake gave us there. Eloise, you want to take the second table?
For the first one, I got 25.
Good.
For the next one, I got 4. And 5. And 4.
Excellent. All right, so then this last one, we were looking to determine whether the tables were proportional or not. Luke, you and Anderson seem to have a lot to say back there. What do you think? The first one is proportional. So when we were multiplying through, you multiplied by 3 every time, straight across. What did you determine for the second one? This is not proportional. If we pay attention to what we're multiplying by, the first one was times 1, then times 2, then times 3, then times 4. If you're multiplying by a different number each time, it is not a proportional relationship. How many people got those correct? Nice job. Good. All right, so for this bottom section, this is a new term that we did not talk about last year, but you're going to hear it a lot over the coming weeks. Every proportional relationship has a scale factor called the constant of proportionality. You guys, you know my iPad stinks. Sound it out. Proportionality. It's an R. Constant of proportionality. So the other way you can think of this constant of proportionality, it's also known as the unit rate, which we did talk about last year. Okay. Constant of proportionality is the same thing as a unit rate per 1. Okay. We're going to pick up here tomorrow. Okay. This can get folded and glued